Okay, it seems like we have good attendance so far. Let's get started for today. So everybody can hear me all right?
Yes.
Yep. Cool. And you should be able to see my screen here with this Jupyter notebook open. I've zoomed in, so I hope everybody can read this. Let me also just quickly hit my local record button just as a backup. We're live again on YouTube. Okay, so the topic today will be command line interfaces, a bit of an introduction in Jupyter Notebooks, and then we'll do some very first steps in Python, and then at the end we'll have an activity, an exercise, which you can do in a group setting. If you have any questions, like if you want to speak up, just like use the raise hand feature on Zoom, or ask the question on Slack. So that we can kind of like, and then somebody from our staff will read it out for you. Okay, great. So command line interfaces, like most people nowadays use graphical interfaces to their computers, be it their phones, be it their computers, or anything like that. But command line interfaces are actually the older way of doing things. So what you would do is you have a text terminal and write down your commands, and then the computer can execute them. So command line interfaces, like your typical, like even information worker might not encounter them all that much, but people that do data science and that do software engineering, they will frequently encounter command line interfaces. There's roughly like, well, there's two big camps of command line interfaces. There's plenty of nuance and many more, but you can say there's the Microsoft command line interfaces, which are basically a derivative of MS-DOS, and more recently PowerShell on Microsoft, and there's Unix command line interfaces which is also kind of what you see on Linux and Mac. But Unix-like interfaces are kind of dominant, and they can now easily be installed on Windows nowadays. And your Anaconda installation, actually, if you're on Windows, comes with one. So if you're in a Mac, you can open up a terminal app to follow along. I personally use iTerm, which is kind of just a little bit of a fancier version. This is kind of like what you see up here. If you're on Windows, you can use the Anaconda prompt that comes with your Anaconda installation to do the stuff that I'll be talking about here. And the Anaconda prompt will also have your Python environment set up correctly. And if you're on Linux, you already know what a command line interface is, I assume. Okay, so some principles and first steps. like when I start a command line interface, like the one I have here, what we see is, let me clear this. What I see here is kind of like, I have some information here. This tells me this is user Alex on computer Alex MacBook Pro. And then here I have my directory. So this directory here tells me the tilde here says this is my home directory. And then I have like the subdirectory data science DS and then a subdirectory 2021 data science lectures. So that kind of gives me the position of where my cursor is. And this percent sign here is the prompt. And these can be different symbols. So we have like, for example, like a greater than sign, a dollar sign, or like a hashtag. There really isn't a difference. The Python prompt will be like 3 greater than signs, for example. So this is just like telling you the command line interface is ready to receive a command. Okay.
We have, I'm not sure what the question is exactly, but in chat someone said PowerShell question mark or command question mark.
Sorry. The Windows and Icona shell still requires DOS syntax. Okay, there is alternatives now. There is like, I haven't been on Windows, unfortunately, in like almost 15 years. So I'm not really an expert on Windows anymore. But there is definitely Cygwin, which you can install if you want to. And there's like a couple of other tools where you can get like a full-on Unix shell. So yeah, if the Anaconda shell doesn't do that, I'm sorry, I missed it. Was that roughly the question? Great. Okay, so where was I? So let's run our first command. And our first command here is going to be ls. And ls is like a very simple command that just lists the content of the directory. And so you can see that in this data science lecture repository, this is a folder that I have now locally on my computer. I have 2 directories, the 01 intro and 02 basic Python, and then a couple of other files. And so what you see here is I have my input, and then the output here is printed. So that's fine. And now we can add parameters to that command. So for example, if I type ls minus l, I get a different formatting. So this is now minus l here. Min means I want this to show up as a list. And in this list here now, I get, like, again, the information about the files, but I also get like the date when it was last modified. I get the file size, and I get some permission information. We're not going to go into the details of this kind of stuff here. Okay, so this is roughly like I execute a command. That command can complete, and then something can be printed or something happens on your operating system. There are also commands that will just keep running until you terminate it explicitly. We'll talk about this a little bit later. Generally, I'm assuming that everybody is kind of aware of like a file hierarchy, but we have, like, on any Unix systems, everything kind of starts at the very root directory, and then I have subdirectories from there. So I could, for example, run the print working directory, and you see, like, I'm currently in the root users Alex DS 21 data science lectures. Okay, so I can do now I can navigate into different directories by running like a cd, which stands for change directory commands. So I can say cd 02 basic Python. And what I did here, I didn't type magically fast, but I just typed the first 2 characters, and then I hit tab, and then I had an autocomplete. So this is actually fairly efficient to navigate a hierarchy like this. Once I've hit enter, you can see that my prompt has changed to tell me I'm now in this subdirectory here. Important things to know is shorthands for different directories. So cd dot would mean, like, dot stands for your current directory. So this will not do anything. If I do cd tilde, tilde stands for my home directory. So this would drop me all the way out to my home directory. And I would now have to do this to go back to my current directory. And then cd dot dot stands for the directory 1 up. So that kind of lets me navigate up in the tree by 1. And so if I do that, you can see that I'm dropped into the root directory of the 21 data science lecture. Okay, I'm going back in here now.
Alex, can I interrupt you with a question that we have on Slack?
Yes, please.
The question is, the syntax the same in Windows? So what exactly do I use for syntax to work on Windows?
So on Windows, the syntax is like the native syntax is different. For example, it's not ls, but it's dir. But as I just said, you can install like a Unix-like terminal on your Windows computer. I do think it's much more useful to know about the Unix and Linux stuff, because if you ever like need to do something on a server, the server is like 97% chance it's going to be a Unix-based server, right? So if you like want to do some big data map reduce job or something like that, you might have to remote SSH into a server, and that will be a Unix shell. So it kind of like, as a data scientist, you have to know a little bit about the Unix shell. Like I'm not going into anything very complicated here. So the equivalent on DOS is going to be very similar. It's like, I think CD is the same. Instead of ls, you say dir, and so on. But there's subtle differences. And on Windows, this isn't all that common, right? Like people have really started using the PowerShell only in the last 5 or 6 years, more extensively. Okay, great. So we've now like listed a directory. We have navigated in directories. Now we want to create a directory. So I can do mkdir, which is make directory, and I can say test directory. Now, of course, I can make up my name here myself. And if I list this, then I can see I have now created a new directory, test directory at 12:35. So exactly just right now. Now I can copy files with this cp command. So for example, I can say I have a new repo .png file here. I say I want to copy this file into my test directory. And this is like, I would have 2 parameters, cp for copy, the source, what do I want to copy? And this could be a full path, right? It could be somewhere else in my file system. I don't have to specify the path here because it's a local file. And then similarly, my target. The target could again be a full path, but I can also do a relative path here. And I have test directory set up. And if I hit enter, and then I can do ls test directory. So now this is going to list the contents of test directory. And you can see that new repo.png is in that subdirectory. Okay, similarly, we can remove files. For example, I can say remove, well, I'm going to change into test directory, and now I can remove the new repo.png file here, and now it's gone. I do not, like if I try to remove the test directory, I get an error message. Basically, this is remove test directory is a directory. And so remove tries to be cautious because directories can contain a lot of stuff, right? So they can be nested. There could be something very deep. So if you want to remove a directory, you have to be explicit about it. So you have to say rm-r test directory, and -r here stands for recursively. So that means delete this test directory and all its subdirectories and everything that's contained within it. So this -r here is necessary for this particular operation. So do we have any questions so far about this? I just want to say that, like, this is more informational. If you're on Windows, you don't really have to install Cygwin, right? Like you can definitely get around just using the Anaconda shell, and we won't be doing a ton of stuff here. I'm mostly showing this to you because we will be like I will be using this later for when I talk about Git, about version control, and so that's useful there. And it's just like something that everybody kind of needs to know, even though we will not be excessively using here. You can actually write complete programs in this kind of like little language that you more or less have here, but we're not going to go into all of this. Okay, I can see that this here isn't really well formatted. Let me quickly fix this. Okay. So here are a couple of other commands that you might want to know. So touch file.txt. Touch is basically says I want to like hit that file, and kind of like update its timestamp, but it also has the side effect of creating a file if it doesn't exist. So if I just want to create a file, I can do this like this. And now if I list this, I can see that I do now have file.txt here.
We have another question in Slack, which is, when you say on Anaconda shell, are you referring to Spider?
No, I'm referring to the Anaconda terminal that you have as part. Like if you start your Anaconda navigator, like this thing here, you don't have that on Mac, but on Windows, you should have like a terminal or something like that in the menu options.
It's the thing that says command.exe prompt, right?
That would be the standard terminal on Windows. But if you can run it from here, that would be like, yeah, then you will have the right environment set. Then you will have Python set up correctly. Okay, so here I've created this file.txt. Now I can do something like echo. This is just like writing what I put in here to the console, right? So that's not all that useful by itself, but it's kind of like still a useful thing to know because we'll use it in a second. I can do can run cat, which is like, well, actually, let's do cat exercise.py. This is like a quick way to look at the content of a file. So that just prints the content of a file onto my console. So here you can see I did cat on a Python, on an exercise file in Python. And we can see immediately what this is. So I don't have to open up like an editor if I just want to quickly look into a file. I can do PWD, which stands for print working directory, which is like shows you exactly where you are. If you have like a configuration like I have, you see that here, but you don't always see that. So sometimes it's useful to do this PWD so that you're just aware of where you are. And then you have this command that's called man, and man stands for manual, and you can do man, for example, ls, and then you can see all of the kind of like options that a particular command or program has. So this is kind of like the documentation for these files. So you don't actually have to go to the internet to look up what the command is. You can just run man and then your command. So I can say man git, for example, to see all of the options that Git has. And I can hit like in here, I have to like hit Q to exit from this kind of like little viewer that I had here. Okay, so basically these are little, like each of these things that I've done here, like print working directory or ls or cd, like they are actually, can think of them as little small programs, right? They are like very, very small programs that can like work together to do various things. And kind of like the philosophy of Unix is to have like small programs, and each of these small programs is supposed to be doing one job well, but they are supposed to take input from other programs and write output to other programs. And so the principal idea here is that you can do things like piping to other commands. So for example, grep, this grep command here is find. You can think of it as find something in, let's say, something like a text file or output. So if I run grep.md on, let's say, a text file, it would return all of the strings that contain md. And now I can do ls, and in here, I actually deleted my Markdown file, so this example isn't all that great anymore, but I'll do ls, and I see I have, for example, like a lot of IPython notebook files. I have a PNG file. But now if I run a pipe ls and then do grep or PNG, that will kind of like, if I execute that, the output of ls is piped into the grep command, and the grep command then executes with the PNG parameter and returns just the PNG files. So if I have a very large directory, for example, with many, many files, this would be a way of very quickly looking at only the images that I have in here. And I can do something like, it doesn't have to be the extension, right? It can be new, and then I have only new repo. So this really just works on the text that we see here. Similarly, like this is piping between commands, but I can also do kind of like piping into files. And I can do things like, for example, create content of a file by piping it into a file. So if I do this, I now have kind of like have test.txt, and that, like, I've written hello world into test.txt, and I can see what's contained in that hello world by, for example, running the cat program. And so if you do that, you can see that there's in fact now the hello world text in there. And I can do like the two greater 10 signs here actually append. So I can say, are you still spinning? And now if I look at what's the content of this file, test.txt or text.txt, I have like appended, well, let's do this again. Now I should have this in text.txt twice. So you can see that I have appended a new line to that file. If I just use a single greater than sign, is like now I'm overriding. And now this text.txt will contain only the overriding text. Okay. So these are kind of like the basics. That's kind of like useful. I'll use some of this stuff later when I talk a little bit about Git. So far, we have used only these like very little programs like ls and echo. And in practice, they're actually not programs anymore. They are like this like typical command line interface, like the Z shell that I'm using here is actually interpreting this, and like it's not a separate application. They are just interpreting it, but you can seamlessly also run like proper programs. So for example, Git is a proper program, or Python is a proper program, or similarly, Jupyter Notebook is a proper program that I can start and execute from the command line. So if I were to run Jupyter Notebook here, then I would launch a new notebook server. And you can see that it dropped me into my browser, and now I have like all of this content in here. And you can see that this is now still running, and I could come, if I want to terminate this, I noticed that I'm in exactly that folder, right? So like this is now, I don't have to navigate here. I'm not in my home directory or anything like that. And if I want to terminate this, I can run Control C, and then I have to confirm this, and now I have terminated this program, right? So I had this program running in the back, or in the foreground. I couldn't do anything else with that particular terminal. Of course, I can always start another terminal if I need to, but I could terminate the running program by hitting Control C. Okay, so next I want to just like go through like very few Git commands that are like the absolute bare minimum that you kind of like need to know to read the stuff that we provide on the lectures. I do have like a separate script, a separate kind of like lecture unit on a more advanced Git stuff, but I am suspecting that I won't be getting to that today. And so I left it still in the repository for you to read through yourself. And if I have time, I might revisit this next lecture. But for today, the very basics here are doing things like cloning. So let me go back out into, I'm creating here now a temp folder where I can show you this stuff. Okay. So now if I want to make a copy of everything we've done, or we are publishing in the lecture, I can run this command here. Git clone and GitHub, like this is actually the URL, right? And so you can go to this website here. And you can see that like, if you want to, like you can just copy that URL to copy a whole repository. You can also like look at other options here. So you can like copy that from here. You can like do this via SSH. I'm not going to go into that. you can open this with the GitHub desktop application, or if you really don't want to do like Git at all, you can just download the whole thing as a zip file and save it in your home directory. So that's kind of like how you can retrieve this kind of stuff. Okay, and now if I run that, I'm like checking out, like this is now downloading all of the stuff on the command line. And now you can see that I have a new directory that's called Data Science Lectures. Okay. And now when we publish updates, you don't actually have to do this again. You only have to do this one time for every repository. Now you could just say git pull. And git pull will retrieve all of the changes that are made. In this case, it tells me, oh, everything is already up to date. No changes are to be made. So this is fine. Here is what this looks like if I have something more complex. This is just an example from a different repository that I was just like working on. And you can see that I have like I get a detailed report of what are the files that have been changed, what are the nodes that have been added, the files that have been added, and so on. So one word of warning, like unfortunately, Jupyter notebooks aren't completely clean code. They kind of contain images, they contain all of these other things. And so if you run any of our lecture notebooks and you work along with me as I'm going through this in the lecture, you will kind of like make changes, even though if you might not even make changes, but just by running a cell, you're already making a change. And so that can cause conflicts, which is kind of like slightly annoying. And so you'll have to deal with these conflicts, and there's a couple of ways to deal with them. So first, there's more details in this dedicated Git lecture. I'm going to give you some two dirty hacks here. The one of them is you take if you made changes to your file, for example, if we teach a lecture and you want to make notes directly in the Jupyter notebook, and then we like make an update to it and you get a conflict, then you should just go into, let's say, your file browser and make it like copy that over and say, this is like lecture 2 my notes.ipython notebook. So you would just go into, let's say, here's my computer, and I would just go in here into my folder where these notebooks are, and now I could just make a copy of this, right? Now this is safe, and I can rename this into something meaningful. And if you do this in just whatever in your Mac Finder, this will be fine, right? This now you have your local copy, and you can just run a new, like you can reset this to what we have updated. This is by the
couple of questions for you. Can I ask from Slack?
Sure.
So one of the questions is regarding if you're using GitHub Desktop, is fetch origin the same thing as pull? So we had that question in Slack and in Zoom, I believe.
Probably. I don't use GitHub Desktop. So okay. I do think it's kind of like GitHub Desktop is a useful tool. I think it's also useful to use the command line, because you're like, it's a little bit more explicit of what you're doing. But I assume that fetch origin is very similar to git pull. If anybody knows the answer to that and uses GitHub Desktop, please just respond to that question on Slack.
Okay, great. And then the last question was, do you have to use sudo if using Linux to clone Git?
No, sudo is a command that changes your permissions. So basically, like you're doing this as an administrator, if you're doing a git clone in your home directory, you should not have to do that. Okay, where was I? We were talking about, yes, conflicts. And so now if you have made like minor changes or nothing you want to keep, you can also run this command, git checkout, and then the file that is causing a conflict that will kind of overwrite what you have locally with what is on the server. And so if you have made no changes and have a conflict, this is the way to do it, because that will just like resolve the conflict and you get the latest version. So copy first or move the file if you want to keep your changes, git checkout if you want to overwrite the changes. And there's this notebook here where I go into a little bit more detail. So just read through this in your own time, and we will revisit it if we have the time for it. Great. So that kind of concludes the very brief introduction into command line interfaces and the very basics of Git that you need to do. Let me just say one more thing. For your homeworks, what you do in your homeworks is you're like manipulating one of these files in your browser, right? So your browser is becoming your development environment. And when you submit this, what we would like you to do is to simply create a zip archive. So you would do something like compress here, and that is kind of like what you want to submit. So this is like your IPython notebook file, zip archive, and this thing here is what you then upload to Canvas for us to include. And sometimes we'll ask you to include the data files there too. We'll talk more about this later, but I'm assuming that everybody knows how to create a zip archive, and you just like have to know where these things live. Okay, so then let's move on. Now I want to do like a very basic introduction into Python. So Python is a programming language. There's many programming languages out there. Python is like has become very popular because it's kind of like simple but yet powerful. It has a lot of like for data science specifically, it has a lot of cool libraries that we'll be using. And so Python is like one of the two programming languages of choice for data scientists, the other one being R, and then to some extent, maybe MATLAB. But there's like lots of machine learning stuff that is compatible with Python, and Python is also like a great programming language for if you do like server side stuff on in a web environment and so on. And Python is kind of like readable, it's usable, it's not that complicated. You don't have like you don't have explicit typing and so on, but we'll talk more about this kind of stuff on Tuesday. Today, we'll just really look at the very basics. And so Python is, again, a program. And so I'm running the Python program by simply like executing it here. And so you can see that now I'm no longer in my terminal prompt, but I have this Python prompt here. And I can see Python, when I started it, I have Python version 3.8 installed. I have installed via Anaconda, and then I have some kind of like help information here. And Python can be used in a couple of different ways, mostly like 3 different ways. Python can be used in interactive mode. So this is what I'm doing here. So if I can actually do like program live here. With the traditional first program that you're supposed to do in every programming language, you have to print hello world, right? So I can do this live in this interactive Python environment. And if I do that, it will actually print that. So this is very similar to what we saw in the command line earlier. And so here, every command, I write every single line step by step, and this is interpreted live. This is happening directly in the Python environment. So this is the one way of running Python. The other way is to write a Python script, a file, and then execute all of them at the same time. And the third way is what we'll be doing mostly is to have some kind of like environment like Jupyter Notebooks where we'll be executing Python in cells. So this is kind of like in the middle between the two of those things here. Okay. So what we've done here is we have executed a function. And we have executed, like we have put a parameter into that function that was the string hello world. And so you see that we have these brackets around them here, and that has been executed. If you have used Python 2 before, then you would have used something like this, which isn't legal anymore in Python 3. So this tells you syntax error. This doesn't work, and Python 2 now has been retired. This is not being supported. So if you're still used to Python 2, this is definitely the time to move on. Okay, I've called a function, I printed it. Now let's define a variable. I can kind of like say I want to create a new variable, my string var, and then I want to set it to are you still spinning? Okay, I've executed this now, and now nothing has happened, right? I've just like this, but that's because that particular line of code doesn't print anything. So it still happened in the background. And so I can check what happened by now printing my string var in the background. So you can see that my string var actually contains the text that I have assigned here. So one thing to note here that's kind of like something that trips up people who haven't programmed before is this assignment. And so I'm using an equal assignment to say, like, this here, the variable here is assigned, like we assign the value on the right side. And typically, like, this is an equal sign, right? It's not an assignment operator, but in most programming languages, this is actually an assignment operator. And if I want to do equals, I would have to do 2 equals sign. So this would be a check for equality. But in like an assignment operator would be just like a single equal sign. Some programming language are actually better at this. They have like a specific assignment operator that often looks like this, but Python doesn't do that. Lots of programming languages don't do that. So like just be aware there's a difference between assignment and equality tests. Like a single equal sign is an assignment, 2 equal signs is an equality test. Okay. Now let's start with a couple of examples where we can do a little bit more, like look at different types of variables and do some operations. So we can have variables like A is 3, B is 2.5, and C is A plus B. So I can do like some very basic math here, right? And now I can print C, and I can see that C actually contains 5.5. And so this is all fine. Like we have lots of these mathematical operators that we can use. They have, we'll talk about lots of operators next lecture, but today I want to talk a little bit about types because they're like, even though A and B are both numbers, they're subtly different. So if we if we write down the type command, the type function, this is a type check. This is like a built-in Python function that checks what is the type of a particular variable. And so I can see type of A is an integer. So this is a natural number. But if I put in type of B, I can see that this is a float, like a floating point number, which means it's a real number. Python has 3 numerical data types: integer, float, and complex numbers. And now, what is the data type of C? Float, exactly. And so why is that? Because I can add an integer to a float, but what I have in the end is actually best described as a float, right? Like if I had stored this as an integer, I couldn't store the 0.5 after the 2. There's plenty of other operations like addition, subtractions, divisions, modulo operators, type conversions, and so on. And we'll explore those in the next lecture. So that's kind of like how far I wanted to go with interactive Python. And now I'm going to like exit Python here. And now I want to look at the different way of running Python, that is by writing stuff in a file. So you if you want to like write a Python script, what you would do is you create a file like firststeps.py. And I can, let's see, what have I open? First steps. Yeah, this does open it with like some weird tool. I'm going to open it here. So I've created this firststeps.py file. And this doesn't do all that much. This just creates a new function. Here we have a little comment. This is a little hard to read. Let me zoom in. This creates a little function. And we'll talk more about how this function is composed. Then we use like an operator here to take the parameter we have in this function, multiply it by 2, we return that value, and then we print this, we call this function and print the output twice in a row, 4 different inputs, once with 3, once with 14.22. I see a question that what is the preferred method to view Markdown files such as homework 0? The homework 0 was the only Markdown file we'll show to you, so you can just look at it in GitHub. GitHub renders Markdowns nicely. These are text files, so they are readable as text files, but there is also like an editor like PyCharm or Xcode or and there's specific Markdown editors that can render Markdown. But Markdown, we will be using it within Jupyter Notebooks, and so that's gonna be kind of like the main way we'll be looking at Markdown text. Okay, so here we have our function definition, we have our print statements, and now I can actually execute this. So I can say Python first steps.py, and now this will run in like instantaneously, seemingly, and it will produce the output here. So now if I wanted to create a more complex program, this would be the way to do it, right? It's like I would write multiple Python files that maybe work together. I would use concept like object-oriented programming. Then I have like a big software piece, and then eventually I start I run this file, and that does whatever I want to do. So that's kind of like the common way to write more complex software would be in files like this, and that's all useful. But we will be mostly like doing Jupyter Notebooks, as I already said a couple of times. So this is more like an FYI to be aware of that. This is like a common way of running Python, but we will be mostly looking at Jupyter Notebooks. Okay, so it's 1:05. We'll do our 5-minute break now, and then when we come back, we'll continue talking about, well, we'll start talking about Jupyter Notebooks. So I'll see you again at 1:10. Okay, let's continue. So here, this is our first interactive notebook. So Jupyter notebooks are kind of like an embodiment of Donald Knuth's, which he's a famous computer scientist, vision of literate programming, right? So the idea of a Jupyter notebook or something like R Markdown is that you write code and at the same time explain what you're doing. And you can do that by writing text, by like writing equations with LaTeX. You can include figures, and then you can include code, and you can directly execute the code. And so you can say, here's what I want to do. Here's kind of like the math that I want to do in mathematical notation, and then you can implement this in code. And so somebody who wants to look at what you did and understand what's going on can do that. And so this is kind of what we are making use of in this lecture. All of these lectures are exactly these kinds of combinations of text, explanations, figures, equations, and then finally code. And so that's kind of like a really cool way of doing data science, because you can document exactly what you do. Notebooks have their downsides, but we'll talk about this maybe a little bit later once we have kind of a little bit better handle at what they're doing. So there's two ways for you to run and execute a notebook. So the first way, this is kind of like what I typically do, is I use my command line interface, navigate to the directory that I want my Jupyter server to be started, and then I run Jupyter notebook here. Now this will like launch a new notebook server, which is what I've done here. You can see what's actually happening is that this behind the scenes, this runs a web server. So if I copy that URL here, I can open up like a new tab with that particular like Jupyter instance. So this is all in the web browser. And like, since I'm running this already, I'm gonna shut this one down again. The other way of starting this is by going to the Anaconda Navigator, which you have already together with like your Anaconda installation. The Anaconda Navigator will be here. And so Jupyter Notebook is one of the examples, and I can click launch here, which will drop me like this. You see it behind the scenes, this is doing exactly the same thing, right? You saw like a terminal pop up. The difference here is now that this drops into my home directory. So I would have to navigate into exactly where the directory that like where the notebook is that I want to like work with. But otherwise, those two ways are exactly the same. And so like I think if you're on Windows, you probably want to do the second way. If you're on Mac or Linux, you probably want to do the first way. But this kind of you can do either way. Either way is fine. There's none of them is better or worse than the other. Okay, so let's look at some of the basics of Jupyter notebooks. First, like Jupyter notebooks are composed of cells. And so a cell is kind of like what you see here in this container with the blue thing on the side. And there's two types of cells. There's text cells and there's code cells. This here is a text cell. Down here is a code cell. I can like edit these cells, these text cells with this little like text language that's called Markdown. And so now I've double clicked on this, or you can hit enter. Evan is asking whether it's better to do like to navigate into your directory first and then run Jupyter there. It really doesn't matter. I usually do that, but it is like a personal preference in some way. So it's really a wash. So here we see a text cell, and this text cell has some kind of like, it's readable as a text cell, but it can also be rendered later. So for example, like one single hashtag means this is a heading of level 1. So if I like now go back into like rendering the cell, you see that this is like a proper heading. If I add 2 more here, this means it's a heading of level 3. And now if you can see that this got a little bit smaller, and so it's kind of like a heading 3. I can do things like adding links. For example, this would be a link here. This is what appears in the text, and this is the actual link. So square brackets and then round brackets, and the actual link goes in here. And so you can see that this is how this looks like. I can make things italic or bold. Italic is like 1 star, bold is 2 stars. this is actually like a nice syntax rendering here that you see italic actually is italic and bold actually is bold. You can show images. So for example, here I have this cute data science cat image that I can embed directly in my notebook cell. The data science cat, if you look here, this is actually in the same directory, right? So here's the file. And so I don't have to specify something more complicated, but I could do something like, if it were like one directory up, I could do this, right? Or if it were a full URL, I could do HTTP and then write down the full URL and it will load the image. But since this is in my local directory, I just have to do this. And so everything that you're editing here is actually written to this IPython notebook file in like a language that's called JSON. It doesn't matter, but we'll look at it a little bit later, maybe, but not for now. So for your homeworks, I've already said this, but I'm going to reiterate it. You will write, like if you edit something in your browser here, it will be written to this homework1 or whatever the homework file is called, .ipython notebook file, and this is what you need to submit. And I'm going to give you like a crash introduction here, but there is like lots of documentation about Jupyter Notebook. Here's a link to this documentation. So some of you might have had issues installing Jupyter. Sometimes it's a little tricky to get an account to work. And there is now a cool cloud-based version of Jupyter. And these are like, this is called a Google Colab. So you can load like a Jupyter notebook into Google Colab, and this is part of Google Drive, and then you can execute this all in the cloud. So if you don't have like a working Jupyter environment for today, you can, for example, just follow along and play with this particular Google Colab that I've uploaded here. I should say that like for your homeworks, we do recommend that you do this locally because there's like reading files is a little bit different in Google Colab because you have to integrate it with Google Drive and then you have security stuff and so on. So it gets a little bit more complicated. But eventually, maybe for your project, if you're working as a team, Google Colab is a good alternative to like doing just files and sending it around. So for your project, this is a cool alternative. And then you can download, like you can download a notebook file and then say like download.ipython notebook, and then you can run it locally again. But just be aware that they're slightly different in the way that you load data into them, and we will be doing that a lot. And so that's why like you should really get the local instance working, but if you want to later collaborate with other people, Colab is a great tool. Okay, so now let's look at the most interesting part of notebooks, is that we can directly embed and write code. So here is like now a code cell. And here I'm running a print function, and this print is of course my usual hello world, and I can execute that cell. And so I can do that by clicking this button here, the run button, or I can just like hit what I'm doing usually is hit command enter or shift enter. I'll talk a little bit more. Command enter just executes the cell, and shift enter executes the cell and moves your cursor to the next cell. So both of them are just like useful options. So we have done our print that we saw before. We have seen an assignment here. And then one thing that is specific here is like I have like at the very end, I have just put in A. And so A here is the output of that cell. And so you see that this was printed, but then here I see this out, like this is kind of like the return value of that cell. And this is the very last statement here. And so we will sometimes print stuff to see what's happening. Sometimes we will use the output value. But if I were to say, do something else here, print test, then you would see A now is gone. It has to be the last statement. So if I delete this again and I run it, then I see my 3 is here again as the output. So one thing that's also useful to know is that these things like A here, I can now use this in a later cell. So this is not available just in the cell, but I can like kind of depend on stuff that I did in other cells. We'll be revisiting this a little bit in just a minute again. So here is a cell where I do a couple of more assignments. I am kind of like creating a couple of data variables. I say age. Let me quickly restart all of this and clear it so that we can have a clean notebook. So now I'm assigning age, gender, name, and a variable called smart. I'm using a numerical value, 2 string values, and a Boolean value here. And then I can do things with these, like in the second cell, right? I can use these elements, and I'm printing here like data science cat, age 2, female, is smart, is true. And I'm doing this by using what's called string concatenation. So I have a variable name, then I am saying plus add, then a comma, a space, age, colon, space, plus age. Age is a numerical data type. So if I use string concatenation here, I have to first convert it to a string. And this is what this built-in function str does. And then I keep concatenating this. And so eventually, like, I have formatted it that it looks like this nice string here. An alternative to doing this concatenation would be like print takes multiple parameters. So it's a function, right? And I can put in multiple parameters, and each of these parameters is then printed with a space in between them. And so this is what I'm doing here. If I run this, you can see that this is slightly different. It's the same data, but I'm now formatting it a little bit differently, and I'm using a different way of formatting it. So for example, I'm saying name, and then I'm saying this here is a new line character. So this is kind of like an invisible character. I say this is like \n. That means I want to like hit enter essentially in my print. So that's why there's an enter between, or like a new line between data science cat and the age. And so I can kind of like keep doing things like this. And if I were to do this, I could just like add as many additional expressions here as I want to. Okay, so here we've seen a code cell. Here we see how we execute code cells. Now, what I've done implicitly, but I haven't really mentioned yet, is that there's 2 different modes in Jupyter Notebooks. There is the command mode and the edit mode. And you can see this by the color of the cell. So if this here is blue, then we are in command mode. And if it's green, then we are in edit mode. And so if I double click on a cell, I switch from command to edit mode. This is a little bit more, there's a question, can you create definitions and use them further down in the notebook? Yes, you can. This is exactly what I'm doing here, right? Look, I've defined those variables here, and then I'm using them later in this notebook here. The tricky thing is that, like, unfortunately, I can actually use them before I define them, in this case even. So this will actually work. That works because I've already run the cell before. If I run the cell for the very first time, this will actually fail. That's kind of like a little bit of a quirk of notebooks, but yeah, we'll cover this later. So going back to modes. Modes are kind of like, it's easy to switch between modes for the code cells. They kind of like just turn from green to blue. For the markdown cells, it's a bigger change, right? So if I double click them, I'm now in edit mode, and I can kind of like hit escape to get into edit, to get out of edit mode into command mode. And depending on the mode, you can do different operations. So in edit mode, it's really mostly about editing the content of the cell. In command mode, it's about like moving the cell around or doing other things. So for example, I could do H in command mode, which would pull up like a useful help menu about all kinds of keyboard shortcuts that I can use in a Jupyter notebook. Or I could say A in command mode, which would add a new cell. And these are 2 code cells. Code cells are the thing that by default, and you can see they're blue. And now I can do like something that, like, I can delete a cell. I can delete a cell by hitting DD, for example. I can also go to cell delete, right, if I want to, or edit delete, delete cell. I can do B, which adds a cell afterwards. I can delete this again. And then if I want to one thing that I frequently want to do is I want to switch between code cell and markdown cell. Right now, if you see these square brackets, it's a code cell. So here you can see this is actually Python. But if I now go back into command mode by hitting escape, and I hit Y, I hit M, then I'm switching it into markdown mode. And now I can like do title. And now I can edit the text. If I now switch this to Python, I hit Y, and now you see this kind of changed into a Python kind of like, you see the square brackets here, and now you can write Python code in here. So you can switch between those two cells. You can, of course, also do this through the menus. And there's different ways of running these cells, like Control, Command, Enter just runs it. Shift and Enter runs the cell and then jumps to the next cell. Alt Enter runs the cell and adds a new one below it. So this is like useful things if you get more familiar with writing this and want to create new cells. Okay, so now we need to think a little bit about what is happening behind the scenes. Like why can I just like run code in a web browser here, right? Like a web browser isn't really like a programming like an operating system that can run code. But what is happening behind the scenes is that we are running kernels. And so here you have your kernel menu. And the kernel menu, just think of it as this, the kernel executes the Python program in the back. And every time you run Control or Command Enter, this stuff, like whatever you execute in the cell, is kind of like executed in that kernel. And the results of that execution are then printed here. And this is like important to know, because in practice, you will do bad things to your kernel. You will make your kernel crash. You will make your kernel hang. Your kernel might be corrupted. And so you need to be able to deal with that, right? And so what you want to do, for example, you can write an endless loop, which means that your computer keeps running and running and running and starting to get hot, and your fan will turn on and your program will never terminate. And to get out of that, you can hit the stop button here. And the stop button terminates the kernel. And so if I do this now, it says interrupting kernel, and now the kernel is actually not working anymore. So this isn't, well, it's restarted the kernel, but I have terminated the kernel and I'm starting a new one. Another thing that I frequently do, and that you always should do before, I restart and clear the output, because that way I can get rid of these dependencies. Like so for example, now if I did this print A here, this was not going to work because A hasn't been defined. Interestingly, if I run it again, it's going to work. Oh, no, it hasn't. Well, in this case, it doesn't work. Yeah. Well, so the point here is that you need to kill your kernel occasionally. And typically you also, before you submit the homework, for example, you should do this restart and run all. That is because that way you can make sure that your homework doesn't have any side effects, right? So when it's easy to make a mistake and to assume that you have defined something, but which you actually deleted. If you do restart and run all, and your notebook runs completely, then you're safe. This is like always the last thing you should do before you submit a homework. And by the way, this did if I do, why the print A didn't work here is like this will work. It just actually no interesting. Yeah, now it works. So yeah, just some of the intricacies of notebooks here. One thing that it's like the notebooks here, they contain everything. They contain the input, the output, all the images, and so on, which is kind of cool because you can also like look at it on, for example, GitHub. You like what I'm doing here. This is not a functional version, right? But I can see like everything here that was executed. I can see the results if I had executed them here. So that's kind of a nice way of doing it, but it's also slightly messy sometimes. Okay, now this was the intro to kind of like notebooks, and now let's talk a little bit more formally about Python. And the very first thing that I want to talk about in Pythons are functions. We have kind of used functions already, but let's look at them in more detail. So like you're all aware of a function in math. A function in math would look like something like this. I have f of x is x squared plus 3, for example. And in a programming language, functions can do exactly this. They can do something like be used to calculate something, but they're also used to act as subroutines. So for example, if I want to have a function that formats my string nicely, I can write a function that formats my string nicely and use this every time I want to format a string. So it's kind of like I want to reuse code. So they have this both, like I want to have like a mathematical function that I want to execute, but it's also a way of modularizing code. And you might hear the terms procedures and methods. They're kind of equivalent to functions for most purposes. There's differences. Methods are parts of like objects and so on, but we will kind of like for now treat them equivalent. So if I say procedure or method or function, I mean the same thing. These are like roughly the same thing. So here is a function in Python. And so what we do here is we define a function that, like, this is the one that we already saw in our like separate Python file. We square x and add 3. And this takes in x. This is exactly what we have here. And then we return a result. But we can, like, if we execute this, nothing happens because this function isn't called. And then in a separate cell, we can call this function. I've called it 3 times now, twice with a print statement and one with a basically returning the output. And so I've called it 3 times for different inputs. And I see the different outputs for that. But now let's take a look at the syntax here. So the first thing is we have this def piece, which essentially says define a function. Then f here is our function name. And in computer science, we tend to say, hey, you don't really we don't handwrite this, and we functions like f are not very user friendly, right? So this would be actually better called square plus 3, because now just by looking at the function, I know immediately what it does. So always try to name your functions in a way that explains what's going on. And then I have parameters that I pass in. So in this case here, my x, and that's in square brackets, and then I have my colon symbol. I've used only a single parameter here, but I can use multiple parameters in my definition. I can use as many as I want. The thing that matters is these are kind of be the variable names that you then use in your local function. The names don't matter when you call a function, right? So here you're saying f of 5, not f of x is 5. So the position here matters. So if I had x, y, z, I could do 5, 2, 3. Then 5 would be mapped to x, 2 would be mapped to y, 3 would be mapped to z. And so these parameters are then available as local parameters in that function. So here I have x available, for example. One thing to note is that after the colon here, this is like the def and the colon, these are required of the syntax. And then the body of the function, everything that is happening in Python is kind of made explicit by indentation. So I indent here by 4 spaces. I can hit tab, but that converts it to 4 spaces implicitly. So you can see I have 4 spaces here. And as long as I keep intending, there's no difference between parameters and arguments, no. As long as I keep writing intended things here, this would be part of my function. And then functions can have, but don't have to have a return statement. And so here I am returning the variable result here. And note that many other programming languages use actually curly brackets to they use something like this. To say this is part of a function, and Python doesn't do that. Python uses indentation, so this isn't gonna work. Okay. So yeah, a function is ended by a new line. So now the other thing that you need to know about, so here is an example of screwed up indentation. So here return result is supposed to be part of the function, but I forgot to intend it. And now if I run this, I get an error message. This tells me syntax error, return outside of a function, right? So that would be like one of the errors that you can get if you do that. If you fix this, it works. Equally, you also can't indent by too much. So here you would get an indentation error. You have an unexpected intent. Chad is asking, you can use tab, like you have to use spaces, but in Jupyter Notebook, if you had tab, it converts it into spaces automatically. So you can hit tab, but it will be spaces. You can't use tab. Python will not, like if you actually went in and edited a text file, you couldn't use tab. So yeah, tab as a keyboard input is fine. You can't intend too much, you would get an indentation error because here, this doesn't make sense, right? Just this isn't a function definition or some other block statement or anything like that. So again, if I correct the indentation, it will work. So related to functions or to other block statements, which we'll talk about next time in more detail, is scope, which is kind of like a critical thing to understand. Scope means that things that are defined within a function are not necessarily available outside of functions. So by default, they are not. So for example, here, this variable, like if I print like this here doesn't take a parameter, it just assigns text to this variable, and then I can print this within that function. And if I execute that, it will print this, right? This works just fine. But if we try to use the variable outside of the function, like the function scope variable here, that's not gonna work. So here, this will result in an error. And that's because the variables that are defined within a function are only visible within a function. Like intuitively, this sounds weird, right? Why am I doing this? But in practice, this is super useful because that's a way of modularizing code. I can like now use, there's a question when starting variables, is it recommended to use camel case? No, Python standard, it says you should use underscores. Every programming language has its own opinions, like if you want to, but it doesn't matter. In practice, the recommendation for Python is to use these underscores, which is different from other programming languages that I'm used to, but it's not that hard to get used to. So function scope is important because it allows us to modularize our code. And generally, you should think of a function. You should be able to use a function without knowing anything about how it's implemented, right? Like if you're using the printf function, you don't want to know anything about its internals. You want to trust that it does what it's supposed to be doing. And you don't want to have some of the variables that are used suddenly polluting your namespace. So that's a very useful thing because it kind of like, I could use function scope, or if I use a counter like I could use my, because I have different scopes, I can use I in many different places. And also libraries, for example, you like that's a way of avoiding conflicts by having these function scoped. If I have like a variable name used inside a library, if I didn't have scoping, I couldn't use the variable outside, but I shouldn't even know about the internals of a library. So it's kind of like a way of encapsulating and making things modular and not having to worry about what's contained in code that somebody else has written. Okay, I can do this. I can say I want to like define a variable outside of a function, and so it's going to be available in the function. So here I'm defining this outside of the function, and if I'm printing it in the function, that works. That is not very clean. It's something that people do especially, and you might catch me doing this sometimes, especially in Jupyter Notebooks, because they are kind of like scripts and like hacky. I want to get something done. For example, when we talk about web scraping, we will not do good software engineering. We will build something that works quickly. But generally, that's not a great idea. So this would be better to do this. Like you would have like a function where you pass in a parameter name, and then you can use the name variable from up here to pass it in. So your function doesn't have to rely on something being defined. So for example, if I moved my function to some other place, if I do it like this might not work anymore. If I do it like this, this is going to work. And finally, there is a way of defining a variable within a function for use outside by using the global keyword. I'm telling you so that you know, but in practice you shouldn't. Like I've never done it, and I don't like. There's good reasons to do it in very specific scenarios, but we will not be encountering them. So here would be like you can use the global keyword to say this variable, I want everybody to be able to see it even outside of my functions. Okay. So that wraps it up for today. Now I want to start the breakout rooms. And Chad is asking why not use classes. Yeah, we will. We'll talk a little bit about object-oriented programming, but we are really like gonna be focused on more scripting in Python. So we won't be doing all that much of like proper software engineering with object-oriented programming classes and so on. So now I've prepared like a little exercise here that kind of recaps some of the stuff that we talked about. It's fairly simple. It's in the 02 exercises. This is prepared for you. We'll create the breakout rooms. You can work together, and if you want to submit this as an activity, you can fill out these cells here. And then submit it into one of the Dropboxes as a zip file, and then you'll get a point for it if you do it by the end of the day today. So I'll set up the breakout rooms, and I'll take any questions before I do that.
Where are the Dropboxes to submit it? Is it just on Canvas?
On Canvas, yes.
Okay.
So on the 02 notebooks in the Jupyter Notebooks file, if we go ahead and start editing or playing around with that, is that I don't know how to explain on your end too, or
we like usually the way we do it is it will not show up on our end. You have to take the file, zip it, and upload it to Canvas.
Oh, okay.
Okay, I'm happy to take questions via Slack. I'll start the breakout room. When you're done, you can just sign off. You don't have to come back to the main room. And yeah, good luck with the exercise.